for people at home, the graphing lesson last time hopefully was a little bit confusing. It is, but I had those three main points at the end. There's really three things we can get off of graphs. We can read the data points, of course, whatever the graphs look like, just like math class. But we can also evaluate the slope of the graph. That's its rate of change. If you had position, that would be velocity, and so on. And we might want to get the area under the curve of the graph, the area between the graph itself and the horizontal axis. But really, they're pretty straightforward. Okay, I went through all that business to introduce you to physics graphs, and just to point out, there's actually a big difference between average velocity and instantaneous velocity. And I think we'll run into that on the homework shortly. But this is a situation that we'll encounter definitely on the practice test, probably on the real test, right? I'll just use a different number instead of plus 20, but it could be 10 or 15 or 30 or something similar, right? It won't be 200, it won't be 1,000, it won't be 16.7 or whatever. Nothing silly, okay? If you throw an object straight up, what happens to its vertical position, y? We're going to graph that with respect to time, starting at y0 equals 0. And same thing with its velocity and its acceleration. Okay, so we'll just do these three graphs of the same motion, different quantities, and compare them. Okay, so first, vertical position. Well, if you read the starting information, y0 equals 0. So we better start right there. Then what happens? What's this graph going to look like? Well, if I try it in real life, it should go up and come back down. Okay, if I'm not quite sure what I'm doing, let's write equation 2 with y's instead of x's. I know y0 is 0, so let's not waste time writing it down. v0t plus, we'll do a over 2 t squared. Okay, oop. The computer is struggling. And for g, please use minus 10 meters per second squared. Okay? So I can, if I start at plus 20 and my first time point is 1 second, I can plug in 20 times 1 minus 5 times 1 squared is 15. So after 1 second, I'm up to 15. After 2 seconds, plug in time t equals 2, so I get plus 40 minus 5 times 2 squared is 4. 40 minus 20 is 20. And if I do 3 seconds, okay, I got 60, but now I got minus 45. I'm back down to 15. Go ahead and check my math. I'm mostly remembering. It's long-term memory gun doing all the work. And then I should be back down. So 20 seconds, and that should make sense. 20 meters per second, excuse me. If you're accelerating down at 10 meters per second, it takes 2 seconds to run out of speed. You're going to count down 20, 10, 0. And then it turns around and falls back down. Back to 10 velocity. And then falling back down faster and faster. Okay? Let's see if I've got enough leash. I don't like that sitting there. Good. Okay. So this is just like you might expect. Plug those numbers in on your own if you have any doubts. But we get a parabola facing down because our t squared term is negative because acceleration is negative. Any questions? Okay, fantastic. I'm going to try to zoom in a bit and move that up. You've done parabolas before. At least the board has enough power. Okay. You've got that parabola on your paper, right? If not, flag me down and I'll scroll back up. Okay, what's happening to the velocity while that is happening? If it goes up and come back down, does it do this? Not at all. Okay, don't just make stuff up. This is velocity now. Okay, if it helps, write an equation. This is equation number 1. So I finally, fifth hour finally called me on it. Why doesn't this list start with number 1? Well, okay, look. Delta x is final minus initial. Average is this stuff. These are just math facts down to delta t equals t minus t0. So if you want to draw a line on your little sheet, and then below that we start with equation 1, equation 2, equation 3. Okay, averages work with velocities. That's why they're 1, 2, 3. They're the first three on College Board's equation sheet too. If you read the given information, you're going to start at plus 20. That's V0. That's what it says up at top. And then you just do plus AT, and A is negative 10. So every second I just lose 10. And I lose 10, and I lose 10. And at 4, it probably hits the person's hand if they didn't move their hand. That threw the ball straight up. Oh, you don't have to graph grade. Yeah, the velocity should turn negative when it's on the way back down. So the velocity graph, where the... Can we zoom out? Yes! The same time point where the slope of that parabola went horizontal, that's where my velocity should cross 0. Because a horizontal line has 0 slope. Of course. Okay. Up. More up. There we go. 2 fingers. More up than that. Okay. There we go. That'll work. All right. And the last one that I would hope would be the easiest, but you wouldn't believe the AP Physics students who see a question like this, and this is your first real physics class ever, so I forgive you. You don't have to get that right. If it's mysterious, okay. But man, in AP, I start to lose it. What do you think?
Stay a straight line across from -10.
Okay. It's a straight line across, of course. The acceleration can only be a straight line across because we only study situations with constant or no acceleration. But make sure your straight line is at -10. People will see like g equals 10 and and just put the straight line at 10, or think g is constant and accidentally put 0. I wonder how much sleep they got. Okay, your acceleration is downward 10 meters per second squared, and when you're falling, it always is. Okay, 10 is close enough. Okay. All right. After a few chapters, we'll come back to that g value and figure out why is it 9.8 or 10? Why is it different far away from Earth or below the Earth's surface? It actually does some weird fun things. Okay. Any questions so far? All right. You feel confident I could give you any of these graphs, like maybe on the quiz tomorrow, and you figure out what's happening with slopes, maybe even areas? Okay. Well, that's the lesson for today. Short and sweet.